Different people drink different types of drinks. Here I have one drink in my hand. Let's see whether it is a solution or not. Actually, this drink is made from sugar, syrup and water. Let's make this solution here. Here I have some water. I take a little amount of sugar and add it in the water. After some time, no sugar crystal can be seen. Sugar dissolves completely to form a homogeneous mixture. Now, the solution consists of sugar and water only. The solution which consists of two substances is called a binary solution. Now, I take syrup and add it in the solution. It is seen again that the syrup dissolves completely to form solution. Thus, a solution is a homogeneous mixture of two or more substances. Here in this solution, you have seen that sugar and syrup are added in small amount and water in large amount. The substances present in the solution in small amount are known as solute, while the substances present in solution in large amount are called solvent. Here, sugar and syrup are solutes. Solution containing large amount of solute is called concentrated solution, while the solution containing small amount of solute is called a dilute solution. The concentration of solution can be measured in a number of ways like percentage composition, molarity, molality, normality and mole fraction. The most common way of expressing the concentration of a solution is molarity. Molarity is actually the number of moles of solute dissolved in 1 liter of solution. Thus, molarity is equal to number of moles of solute divided by volume of solution in liters. Let's make 1 molar solution of sodium chloride. As you know, 1 mole of sodium chloride is equal to, has mass equal to atomic mass of sodium plus atomic mass of chlorine. Thus, 23 plus 35.5 gives us 58.5 grams. This means that 1 mole of sodium chloride is equal to 58.5 grams. Let's weigh 58.5 grams of sodium chloride. Here I have salt, that is sodium chloride. Now I weigh 58.5 grams of sodium chloride. Here we have 58.5 grams sodium chloride. We will mix this sodium chloride in 1 liter of water to make 1 molar solution of sodium chloride. Solution can exist in any of the 3 physical states of matter, that is solid, liquid and gas. Here we discuss few aspects of aqueous solutions and their electrolytic behavior. The solution in which water is taken as solvent is called aqueous solution. Water is a polar solvent and it dissolves a little bit of almost everything. When ionic salt like sodium chloride is dissolved in water, it dissociates into sodium ions and chloride ions. Water molecules surround these solute ions and interact with them. The process in which the solvent molecules surround and interact with solute ions is called solvation. And if water is used as solvent, the process is called hydration. Similarly, hydrated copper sulfate crystals contain 5 water molecules and hydrated sodium sulfate crystals contain 10 water molecules. In ionic compounds, negatively charged ions are larger in size than positively charged ions. Thus, the number of water molecules attached to positive ions is greater than those attached to negative ions. Reason for this attachment is the high charge density of positively charged ions. That is why in hydrated copper sulfate, 4 water molecules are present with copper ions and 1 water molecule with sulfate ions. Dear students, as you come to know that solute dissolves completely in water to make a homogeneous mixture. But there are a few salts which are not completely soluble in water. For example, silver chloride is such compound. When it is dissolved in water, it dissolves to produce a solution, but a limit reaches when it stops to dissolve. And a saturated solution of silver chloride is formed. At this point, silver chloride solid is in equilibrium with its ions. Silver chloride in water ionizes to silver ions and chloride ions. The equilibrium constant expression for this equation is Kc is equal to silver ions multiplied by chloride ions divided by concentration of silver chlorides. Since the effect of undissolved salt remains constant, thus the equilibrium constant expression for this equilibrium is Kc is equal to product of silver and chloride ions divided by K. On rearranging, the equation becomes Kc into K is equal to product of silver and chloride ions. The new constant is called Ksp or solubility product constant, which is equal to product of silver ions and chloride ions. If the ionic product, that is the product of silver ions and chloride ions, is less than Ksp, the solution is unsaturated. One of the major applications of solubility product is that it is used to predict whether a precipitation will occur in a solution or not. If the ionic product, that is the product of silver ions and chloride ions, is greater than Ksp, precipitation will occur in the solution. Dear students, now we come to electrolytes. Electrolytes are solutions or molten compounds which conduct electricity and undergo a chemical change. Let us now move to laboratory where we will see how the electrolysis happens.
Dear students, as you know that aqueous solutions of all electrolytes conduct electric current. This is a non-spontaneous process, and such a non-spontaneous process in which chemical reaction occurs due to the passage of electric current is known as electrolysis. Electrolysis results in the decomposition of the substance. Today we will discuss the electrolysis of concentrated aqueous solution of sodium chloride. The apparatus which we use for this purpose consists of a container. We have a beaker here, 2 inert electrodes. These are of graphite, wires which are connected to the respective terminals of the battery, a source for electric potential. We have a source of direct current here. When these wires are connected to the respective terminals of the battery, the reaction starts and the solution becomes basic in nature. We have concentrated aqueous solution of sodium chloride, and you know then that when sodium chloride is added to water, it ionizes into sodium ions and chloride ions. You can see from this equation that sodium chloride ionizes into sodium ions and chloride ions. Now when the chemical reaction occurs due to the passage of electric current, chloride ions will move towards anode and water will get reduced at cathode. You can see from this half reaction which shows oxidation at anode. Chloride ions will give up electrons at anode. As a result, we obtain chlorine gas at anode. Similarly, at cathode, reduction process occurs, that is, water takes up electrons at cathode and hydrogen gas is released as a result. Such a process in which both the reactions, that is oxidation, reduction, are occurring side by side, such reaction is known as redox reaction. And redox reaction in this case can be shown by this equation: chloride ions plus water plus sodium ions will give chlorine gas at anode, hydrogen gas at cathode, whereas sodium ions and hydroxyl ions will remain in the solution. That is why we obtain basic solution and we can obtain this sodium hydroxide from this solution. Okay, do you have any question? Yes?
Ma'am, what is the industrial application of this process?
Well, the industrial application of this process is to obtain sodium hydroxide on large scale.
Excuse me, ma'am.
Yes?
Why hydrogen gas is liberated at cathode instead of sodium?
Well, hydrogen gas is liberated at cathode instead of sodium due to higher reduction potential of hydrogen.
Dear students, let's see how a galvanic cell is prepared.
Dear students, cell is a source of energy. A cell is any vessel or container in which a chemical change take place. A cell can be constructed by placing two electrodes in a container. Now it becomes a cell. Electrodes are devices through which electric current enters or leaves the solution. But if we place a single electrode in a container of its own solution, it is called half cell. This is salt bridge. A salt bridge contains potassium chloride in gelatin. This is gelatin. We make galvanic cell by placing salt bridge between the two solutions, and copper electrode is placed in copper sulfate solution and connecting it with voltmeters, and zinc electrode placed in zinc sulfate solution. Now this zinc electrode is connected with voltmeters. In this way, the whole circuit becomes complete and energy is produced which can be measured from the voltmeters. Now what is the function of salt bridge? Through salt bridge, movement of ions takes place. When zinc metal dissolves and it comes into the solution, this solution becomes positively charged. The function of salt bridge is to make both the solutions electrically neutral. From this salt bridge, chloride ions, they come into zinc sulfate solution. In this way, it becomes electrically neutral. When copper ions, they are deposited at copper electrode, this solution becomes negatively charged. So potassium ions from salt bridge, they move into copper sulfate solution. In this way, it becomes electrically neutral. So salt bridge, it makes both the solution electrically neutral by the movement of positive and negative ions in both the solutions. Now, what are the applications of galvanic cell? Galvanic cell is an easy and portable source of energy. The best example of galvanic cell is the dry cell. This dry cell, it can be used as a source of energy. And another application of galvanic cell is a battery. A battery is a collection of cells. Now each hole represents one cell, and collection of these different cells is known as battery. Yes?
So which electrolyte is taken in salt bridge?
In salt bridge, mostly potassium chloride is taken in gelatin, but in addition to potassium chloride, potassium nitrate can also be used, which serves the same function as potassium chloride.
Liquid water ionizes to produce hydrogen ions and hydroxyl ions, and the equation for this ionization is liquid water is in equilibrium with hydrogen ions and hydroxyl ions. The equilibrium constant expression for this equation is K is equal to hydrogen ions multiplied concentration of hydrogen ions multiplied by concentration of hydroxyl ions divided by concentration of water. Since the amount of water always remains constant, thus K into concentration of water is equal to product of hydrogen ions and hydroxyl ions. This constant is called Kw, or ionization constant of water, and is equal to ionic product of hydrogen and hydroxyl ions. The ionic product constant Kw for water at 25 degrees C is equal to 10 raised to power minus 14. It means that when the concentration of hydrogen ions is equal to 10 raised to power minus 7, or the concentration of hydroxyl ions in a solution is equal to 10 raised to power minus 7, the solution is neutral. If the concentration of hydrogen ions is less than 10 raised to power minus 7 and concentration of hydroxyl ions is greater than 10 raised to power minus 7, the solution is basic. If the concentration of hydrogen ions is greater than minus 7 and concentration of hydroxyl ions is less than 10 raised to power minus 7, the solution is acidic. It means that concentration of hydrogen ions and hydroxyl ions are a measure of acidity or alkalinity of the solution. Hydrogen ions and hydroxyl ion concentrations are usually expressed as pH and pOH. pH is the negative log of hydrogen ion concentration, or pH is equal to minus log hydrogen ion concentration. Similarly, pOH is the negative log of hydroxyl ion concentration, or pOH is equal to minus log of hydroxyl ion concentration. The sum of pH and pOH for water is 14 at 25 degrees centigrade. Dear students, let's talk about redox indicator. These indicators are highly colored reagents or dyes which undergo a change in color in oxidation reduction reactions. These show different colors in oxidized and reduced form. Potassium permanganate is an example of such an indicator. Let's understand the use of redox indicator with the example of a titration. The reagents that we have used are potassium permanganate, which is the titrant, and aqueous solution of ferrous sulfate, which is the titrand. Potassium permanganate is taken in burette, and 10 ml of ferrous sulfate are taken in conical flask. Half test tube of dilute sulfuric is added in ferrous sulfate solution, and then it is titrated against potassium permanganate solution. The end point is marked by a pink color of solution. Phenolphthalein and methyl orange are commonly used as acid-base indicators. Phenolphthalein is colorless in acid solution while imparts green color in basic medium. Methyl orange is red in acidic solution while it gives yellow color to basic solution. Let's understand the use of acid-base indicator with the help of a titration. Here we have taken aqueous solution of HCl in burette and solution of sodium hydroxide in titration flask. Indicator that we use in this titration is phenolphthalein. We add a few drops of phenolphthalein in this solution. Phenolphthalein imparts pink color to the basic solution. Now we titrate it against hydrochloric acid. At the end point, the solution is turned colorless, which indicates the end point of titration. The third type of indicators are precipitation indicators, and these give colored precipitate which show the end point of the titration. The use of the precipitation indicator depends upon the type of reaction involved. pH of a solution does not remain constant. Thus, it is very difficult to preserve a solution at a particular pH. If the solution is contained in an open container, it will react with air, it will absorb carbon dioxide and become acidic. And if it is contained in a glass bottle, it will react with the alkaline impurities present in glass and become alkaline or basic. In order to avoid this difficulty, buffer solutions are prepared. Buffer solution is the solution that tends to maintain its pH when an acid or an alkali is added to it. Buffer solutions are used in many industrial processes like electroplating, manufacture of leather, photographic materials and dyes. In this program, we have learned that solution is a homogeneous mixture of two or more than two substances. KSP value tells us whether the solution is saturated, unsaturated or supersaturated. Electrolytes conduct electricity in aqueous solution or molten state, and there are two types of electrolytic process. Electrolysis, in which electric current is responsible for a chemical reaction, that is electrolytic cells of fused and aqueous sodium chloride. A spontaneous reduction reaction responsible for the production of electric current, that is galvanic cell. Acidity and alkalinity of a solution is measured in the terms of pH and pOH. Change in the pH of a solution can be detected by the use of indicators. Solutions which maintain their pH in acidic or basic media are called buffers. Dear students, we will see you in the next program. Till then, Allah Hafiz.